Hello, in this lecture, we'll first show that Gaussian curvature of a surface remains invariant under the change of parameterization. And after that, we'll compute Christoffel symbols of some surfaces. First, let us discuss about Gaussian curvature. Let us take a regular surface S in R3. And let U sigma and U tilde sigma tilde be two surface patches for S such that intersection of sigma U and sigma tilde U tilde is non-empty. Okay, so now let EFG be the coefficients of the first fundamental form for the surface patch U sigma and E tilde, F tilde, G tilde be the coefficients of the first fundamental form for the surface patch U tilde sigma tilde. So then, how this coefficients E tilde, F tilde, G tilde are related to EFG? So it is given by this matrix equation. So matrix E tilde, F tilde, F tilde, G tilde is equal to J transpose EF FG J, where J is this matrix del U tilde, del U, del V tilde, del V, del U tilde, del V, del V tilde. So J is this matrix. And similarly, if LMN respectively L tilde, M tilde, N tilde be coefficients of second fundamental form, so then L tilde, M tilde, M tilde, N tilde. So this matrix, so this will be again equal to J transpose L M M N J. Okay. Now, so the Gaussian curvature, it is the determinant of this matrix. E tilde, F tilde, F tilde, G tilde, inverse. Inverse of, take the inverse of this matrix and multiply it with L tilde, M tilde, M tilde, N tilde. So this determinant of this matrix gives the Gaussian curvature of the surface with respect to the parametrization U tilde, sigma tilde. Okay. So this matrix, so this in fact it is the matrix is the differential of the this Gauss map. Okay. So now determinant of this is equal to determinant of, so E tilde, F tilde, F tilde, G tilde is given by this matrix equation. So from here, so we have J inverse EF FG J transpose inverse multiplied by J transpose L M M N is equal M N multiplied by J. So this is equal to determinant of EF. So here this inverse will come. So EF FG inverse L multiplied by the matrix L M M N. So this determinant is equal to the Gaussian curvature of the surface with respect to the surface patch U comma sigma. Okay, so therefore we have shown that, so Gaussian curvature does not change, or it remains the same. Gaussian curvature remains the same under the change of parametrization. Okay. All right. So now let us compute Christoffel symbols of some surfaces. Okay. So first, let us take a plane or cylinder. The first fundamental form of this plane or cylinder, it is given by d square equal to du square plus dv square. So the coefficients of first fundamental form are E equal to 1, F equal to 0, G equal to 1. Okay. So now we want to find the crystal symbols. Now let us again go back to those equations. So gamma 111 E plus gamma 211 F is equal to half EU. So EU is the partial derivative of E with respect to U. The second equation is gamma 1 1 F plus gamma 2 1 1 G is equal to Fu minus half EB. The third equation is gamma 1 1 2 E plus gamma 2 1 2 F is equal to half EB. The fourth equation is gamma 1 1 2 F plus gamma 2 1 2 G is equal to half GU. The fifth one is gamma 1 2 2 E plus gamma 2 2 2 F is equal to FB minus half GU. And the last one is gamma 1 2 2 F plus gamma 2 2 2 G is equal to half GB. Okay, so let us call this first pair of equations to be 1, the second pair to be 2, and the third one to be 3. Okay, so now for plane and cylinder, so the coefficients are constant, so U, it will be equal to 0. So all the partial derivatives of EF G are 0. Okay, so therefore from equation 1, so what we'll get? So from equation 1, so gamma 1 1 1, so this will be okay, so let us again go back to this thing. So E is 1 here. So gamma 1 1 plus gamma 2 1 1 times 0 is equal to 0. So therefore, so this gamma 1 1 is equal to 0. Okay, and similarly from this equation, so gamma 2 1 1 is 0. So gamma 2 1 1 is 0. And now from equation 2 and 3, so we'll get that. So gamma Kij is equal to 0 for all I j k belonging to the set 1, 2. So the crystal symbols for plane and cylinder, it vanishes. Okay. So now let us take surface of revolution. So let us take this following parameterization. So sigma ub is equal to fb cos u comma fb sin u comma GB. So at this FB, it is not equal to 0. So E is equal to the inner product of sigma U with sigma U. So this will be equal to FB square. F is equal to the inner product of sigma U with sigma B. So this is equal to 0. And G is the inner product of sigma B with sigma B. So this is equal to F prime B square plus G prime B square. So the partial derivatives are as follows. So EU, so this is equal to 0. EB is equal to twice F prime. FU is equal to FB equals to 0 because F is 0. G, it is a function of B, so GU is 0 and GB, so this is equal to twice of F prime times F double prime plus G prime times G double prime. Okay, so you have this thing here. And from the equations in 1, so what we'll get? Gamma 1, 1, 1, E plus gamma 2, 1, 1, F is equal to 0. And gamma 1, 1, F plus gamma 2, 1, 1, G is equal to 0. Okay, so from here, so this will imply that, so F is equal to 0. So from this first equation, so what we'll get? We'll get gamma 1, 1, 1, 1 is equal to 0 because gamma 1, 1, 1 times E is equal to FB square. FB is not equal to 0. So therefore, gamma 1, 1, it has to be equal to 0. Yeah, so in the second equation, so we'll have here, this is equal to minus F times F prime. So the second equation here is gamma 1, 1, 1 F plus gamma 2, 1, 1 G is equal to minus F prime. Okay, so from here, so what we'll get is gamma 2, 1, 1, it is minus F prime divided by G. So it is equal to minus F prime divided by G, which is equal to F prime square plus G prime square. So similarly, we can find the other histopal symbols. So gamma 1, 1, 2. So this is equal to F prime divided by F square. Gamma 2, 1, 2, it will be equal to 0. Gamma 1, 2, 2, it is equal to 0. Gamma 2, 2, 2, it is equal to F prime times F double prime plus G prime times G double prime divided by F prime square plus G prime square. Okay, so therefore, we have computed the crystable symbols for a surface of revolution. And now if I take a sphere or torus, we can compute the crystable symbols. Okay, so I'll stop here.